My name is Peter Gabriele. I'm Director of Emerging Technology for Secant Medical in Percy, Pennsylvania. My presentation is entitled Getting to the Holy Grail. One of the problems in the technology, vascular technology for cardio is getting to a small bore vessel, small enough below 6 millimeters, which is approximately quarter of an inch. One of the problems is that PTFE and polyester are not manageable below 3 millimeters. So we've developed not only a process, but we've also developed a material that will allow us to get to that construct dimension, as well as provide some benefit to the types of tissue response that we would get. One of the issues in biomaterials right now is that there's a limited resource, really, and particularly a limited resource when it comes to cardiovascular. And one of the predominant issues is what's called compliance matching. Compliance matching is actually having the construct or the luminal device take on the same engineering properties as a natural or native vessel would. And so one of the important things is to try to find biomaterials that mimic or biomimic the actual activity in vivo of the natural vessel. One of the areas that we consider to be a trend going forward in the future is a concept called endogenous regeneration. Big word, but basically it amounts to letting the body heal itself. Just about everything that we do today is based on synthetic materials, and so really the cardiovascular landscape right now really constitutes a synthetic repair where there's an awful lot of man-made consequences to this, such as scar tissue and limited so-called service life. The gap that we have to bridge to get to the emerging technologies is to try to match materials to the biology, to the biophysiology, and make that match in such a way that we don't interrupt or interfere with any particular natural activity of the organ system. So for instance, if you think of PET as the typical and traditional graft material, that's like having a very stiff stovepipe stuck in between the two ends of a vessel. One of the problems is that you lose the hemodynamic capability of the stretching and compliance and all the rest of the things that come with pulsatile action. On the other hand, if you could substitute that same section with a material that mimics the actual elastomeric biomaterial activity, then you're more likely to reduce downstream consequences such as hyperplasia, clotting, and some of the other things that go along with actually putting grafts in. I think one of the key considerations is to try to find a vendor or partner to work with who truly understands the FDA compliance and the regulatory process. There's an awful lot of miscommunication as to what we can do and what we can't do and what we should do and what we shouldn't do. The reason for some of the limitation in the selection of biomaterials is that people are just generally afraid of what the downstream long-term commitment is going to have to be to develop the particular product. But that doesn't necessarily have to be the case if you make a judicious choice based on the technology of the materials that have been tested not only in universities but in other areas of research. So I would say one of the trends going forward for OEMs is to have a little bit more courage to fail, a little more openness to try and look at materials, because this is the only way we're going to overcome some of the man-made disasters that we've created in the last 10, 15 years. The MD&M experience is really one that I think is going to provide an awful lot of opportunity for the future. One of the things that I've noticed is there's a really nice integration of academics with commercial people here, and that's important because translating the science from academia into the commercial space is sometimes considered to be an awful difficult expectation by both parties. The problem is academia is not geared up to understand the commercial constraints, and the commercial landscape doesn't actually know or is capable of investing the time and energy into the fundamental science that goes into this hopefully future technology. What's going on here is actually an integration of both the academic and commercial, and I think what that's going to do is accelerate the process and give each one of the parties some insight into what each one of them has to do to make the product offering a success.